Hey subscribers, welcome back to another episode of Science with Surback. Today what we're going to be talking about is phase changes. And before we get into the details of these notes, I would like to outline a couple of objectives that you should be able to accomplish by the end of this video. Objective number 1, explain how the addition and removal of energy can cause phase change. And objective number 2, interpret a phase diagram. So it's really important here that we understand what a phase change is and how we can get to that point in state here. So a phase change is this. We can have phases of a substance exist when two or more states, so states of matter are solid, liquid, or gases, of a substance coexist as physically distinct parts of a mixture. So again, the key thing here is distinguishing between the term phase and states. State of matters are solid, liquids, and gases that we commonly think of how a piece of matter can exist. And then phases is saying, hey, we got to have two of these substances or two of these states simultaneously exist. Now, a great example of a phase change or seeing a phase change is a glass ice water. One of the phases is the solid phase with our ice, and the other state is the liquid water phase. Now, phases can change or be altered if we have energy added or removed from one system or another. Now, throughout these set of notes, we're going to use the different phases of water. And one of the three phases of water is ice, which is the solid phase. The liquid phase of water is just referred to as water. And the gas phase of water is known as water vapor. All right, so let's go through each of the 6 types of phase change, starting with melting. Now, as we go through this, it's going to be important to pay attention to determine if this phase change either requires or releases energy. That's a very significant thing that we need to be able to identify. So melting is going to occur when a solid is changed into a liquid. Now, melting is going to require energy to be transferred into the system. Now, when heat or energy flows into a solid object, melting is going to occur. Now, keep in mind, heat is the transfer of energy from an object at a higher temperature to an object at a lower temperature. So now let's use our example, ice. When ice begins to melt, heat energy is transferred from the surroundings into the ice. When that solid ice absorbs enough energy, the hydrogen bonds are broken and water molecules begin to separate. As the hydrogen bonds break apart, the water particles are going to move apart when the ice melts into that liquid water. Now, since we're talking about melting, we can also talk about the melting points. Now, we need to break the melting point into 2 different categories, one of which is for the crystalline solid. Now, the melting point for a crystalline solid is the temperature at which the forces holding the crystal lattice together are broken and the substance becomes a liquid. Now, the other point which we need to make here about a melting point is for amorphous solids. Now, amorphous solids, remember substances like rubber, the melting point is difficult to determine because these solids tend to more act like liquids than a solid in a solid state. All right, so we've gone over our first phase change. Now we can move to our second phase change. And our second phase change is vaporization. Now, vaporization is defined as the process by which a liquid changes to a gas or vapor. Now, to vaporize a substance, it is going to require energy to be added to it. An example of this is water under normal conditions here must reach a temperature of about 100 degrees to be able to go through vaporization. Now, an important term that we need to talk about here is evaporation. Now, evaporation is vaporization only at the surface of a liquid. Now, evaporation occurs at cold temperatures when temperature rises and more molecules achieve the minimum energy required to escape the liquid. Now, evaporation is the same process your body uses to control its temperature. Now, since we're on the topic of vaporization, we also need to talk about vapor pressure. Now, vapor pressure is defined as the pressure exerted by a vapor over a liquid in a closed container. Now, for water vapor that evaporates in a closed container, it will exert a pressure on the surface of the liquid. All right, so now we can move on to talk about boiling point. It's kind of an extension here of what we have with vaporization. So the boiling point is defined as the temperature at which the vapor pressure of a liquid equals the atmospheric pressure. Now, we need to talk about two scenarios. The first scenario is liquids below their boiling point. So what is happening here is that the atmospheric pressure pushing down on the liquid is greater than the pressure that is pushing up on the air from that liquid. And as a result, the vapor pressure is less than the atmospheric pressure. Now, let's talk about liquids at their boiling point. What happens here is the liquid molecules have enough energy to vaporize. And as a result, you get bubbles of the vapor that collect below the surface of the liquid rise to the surface of the liquid. At this point, the vapor pressure is equal to the atmospheric pressure. Now, our final thing that we need to talk about here is liquids above their boiling point. Here, bubbles that formed in that previous step are going to erupt from the surface of the liquid. And in this case here, the vapor pressure of that liquid is greater than the atmospheric pressure. All right, so now we can talk about our final phase change that requires energy. And this final phase change that requires energy is called sublimation. Now, sublimation is defined as the process by which a solid changes into a gas without becoming a liquid. Now, this process requires a lot of energy. And a good example of this is dry ice. Now, dry ice, what happens here and why we get sublimation is when we have solid carbon dioxide and we bring it out into regular standard room temperature conditions and pressure there, it's going to change into a gaseous carbon dioxide. Now, dry ice, in case you're wondering here, is used to keep objects cool during shipping, and because of the way it sublimes, it doesn't cause water damage. Now, we can also talk about the sublimation of water. Now, if you're wondering how this can happen, well, solid water or ice can sublime to a gas when left in a freezer over a long period of time. Now, this process of subliming water can be shortened when extremely low pressures are used. Okay, so we've talked about the three phase changes that occur and require energy. Now we can talk about three phase changes that occur and release energy. So we start out here with condensation. Now, condensation is defined as the process by which a gas or vapor becomes a liquid. Now, condensation is the reverse process of vaporization. Now, during condensation, energy is released. What also occurs is that the velocity of a substance or those particles contained within those substances are going to decrease. Now, let's consider our condensation of water and take a few examples into account. The first example is dew. And so specifically what happens when we get dew on the grass, we're having the temperatures, or as the temperatures decrease their heat from the vapor molecules, is going to be transferred to a surrounding object and the water vapor begins to condense. Now, as the water vapor condenses, it forms droplets on surrounding objects like windows or grass. Now, another example of condensation of water is fog. So what has to happen for fog to occur is that a layer of air near the ground cools. As this air cools, the water vapor in the air condenses and produces fog. Okay, so now we can move on to another phase change that releases energy. And the phase change that releases energy here is known as freezing. Now, this is the process that occurs when a liquid becomes a solid. Now, this is the reverse process of melting. Now, in freezing, energy is released. And what we have to keep in mind here is that the particles lose kinetic energy and their velocities decrease. Now, while we're talking about freezing, we can also talk about the term of a freezing point. Now, the freezing point is the temperature at which a liquid is converted into a crystalline solid. Now, let's put these concepts of freezing into our example of freezing water. So, for example, if you take a bottle of water and you place it into your freezer, what happens is this. The heat is going to be removed from that liquid water. As this heat or energy is reduced, the liquid water becomes less likely to flow and eventually stops flowing. Now, when that water stops flowing, it is going to become a solid. Okay, so we've gotten two of our three phase changes where we release energy. Our last one here is called deposition. So deposition is going to happen, or is going to be defined as the process by which a gas or vapor changes directly into a solid. Now, deposition is the reverse process of sublimation. Now, in the process of deposition, heat is going to be removed from a gas very, very quickly. Now, again, just so we're aware here, this is releasing energy. Now, deposition, you may be looking at that definition and think, yeah, when is that going to occur? But there's some actual common examples that we experience almost on a yearly basis. So one example is frost. Now, frost is the same type of frost that occurs on your window when it gets really cool out, and it's specifically going to occur when water vapor comes in contact with a cold window and it forms a solid deposit on the window. Now, another example here is snowflake formation. What happens here when we have our snowflake formation is this. We have water vapor in clouds that gets changed directly into solid ice crystals. Okay, so to piece together all 6 of our phase changes, what I have here is a diagram that we are going to fill out together. Okay, so we have this diagram here with our 3 states of matter, and in between each of these states of matter are these boxes. Now, we're going to go in numerical order and talk about each of these phase changes that occur here. Now, going in order, starting with number 1, we are going from a solid to a liquid, and this process is known as melting. And so down below here, I am going to put a number 1 to emphasize melting. And melting here Melting is going to be when a solid changes into a liquid. Now, the process of melting here is going to require energy. Okay, so now if we look here, box number 2, a liquid going to a gas. Okay, a liquid going to a gas. That process there is known as vaporization. And again, I'm going to do the same thing here. For number 2, I'm going to write down vaporization. And vaporization is going to be when a liquid changes into a gas. And again, this process of vaporization is going to require energy. Okay, so moving to number 3, we're going from a solid to a gas. Now that process there, process number 3, is known as sublimation. And again, I'm going to write down number 3 here. And I'm going to write down sublimation. And sublimation is when a solid directly changes into a gas without first becoming a liquid. And again, sublimation is going to require energy. Okay, so now we can switch gears here and we can go to processes 4, 5, and 6. So in process 4, a gas is becoming a liquid, and we call this process condensation. Now, again, we're going to start out here with process number 4. And we're going to call this condensation. And condensation is when a gas becomes a liquid. Now, in this process here, energy is going to be released. And now we can move to process number 5, where a liquid is becoming a solid. And we know this as freezing. And so again, I'm going to put number 5 here as freezing. And with freezing here, we have a liquid changing into a solid. And this process here of freezing is also going to release our energy here. And we have one more category left, and that is process 6, where a solid is going to change directly into a gas is going to change directly into a solid. And we refer to that as deposition. And so what I'm going to do here is write down number 6 and put deposition. And deposition is when a gas changes into a solid without first becoming a liquid. Now, this process here of deposition also releases energy. So what I want you to take away out of this is, what state of matter does our phase change go to and from, and if it requires or releases energy. Now, hopefully you've noticed here, anything that required energy I wrote in red, and anything that released energy I wrote in blue. Now, we're going to talk about one more main topic here, and that is the concept of phase diagrams. So, phase diagrams, the first thing that we need to identify is this. These phase diagrams are graphs of pressure versus temperature that show what phase a substance exists in under different conditions of temperature and pressure. Now, each phase diagram for each substance is going to be different. And that is because each substance has a different normal freezing and boiling point. Now, there are two variables on a phase diagram, one of which is temperature, and the other is the pressure. Now, the temperature is on the x-axis, and the pressure is on the y-axis. Now, let's talk briefly about the temperature's effect on the phase of the substance. So, as the temperature of a liquid increases, it will cause more liquids to vaporize to a gas. Now, as the temperature decreases, it will cause more liquid to freeze to a solid. Now, let's talk about pressure's effect. So as the pressure of a liquid increases, it will cause more liquids to condense to a solid. And as pressure decreases for a liquid, it will cause more liquid to vaporize to a gas. All right, so let's actually see a phase diagram and label some different parts. So we start out here with our phase diagram. And we can see on the y-axis, we have the pressure, which is in the units of atmospheres, and then the temperature, which is on the x-axis, and it is in the temperature or the unit of degrees Celsius. Now, we're going to start off by labeling each region that is composed of a phase diagram. So, this first region, which is in the upper left-hand quadrant, is for a solid. So if you have conditions with certain pressures and certain temperatures for, in this case, CO2, we would have in this upper left-hand position our solid. Now, our other portion here, or our other two states of matter that we need to talk about here are the upper right-hand quadrant, which is the liquid phase of matter. And down below here, this right here is the gas phase of matter. So again, any conditions that are in between this region, I have my fingers pointed in, is a liquid. Anything in these conditions here is a gas, and same thing with a solid. So they each have their own distinct regions. Now, I want to talk about 2 points that I have labeled on this particular chart. And this first point here is this point right here in the middle, and that point right here in the middle is known as the triple point. Now, the triple point is defined as a point on a phase diagram that represents the temperature and pressure where all 3 phases of a substance coexist. Now, the other point I want to talk about here on our phase diagram is this point right here at the top. Now, this point here is known as the critical point. Now, the critical point is the point on a phase diagram that shows where a liquid and gas coexists and is the location of a supercritical fluid. Now, again here, this point is where we have our liquid and our gas. They are what they are having the same density and they coexist here. So you have this supercritical fluid, which for CO2, this is actually what dry cleaners use. They get that fluid up to supercritical temperatures and allow that clothes to be dry clean. Now I want to talk about 3 lines, and I know they're kind of hard to see in a black and white photo, but I'm going to highlight those with some different colors. So I'm going to start out here, and I'm going to circle this line from the triple point all the way to this top of the diagram. And so right here in green is the line that shows the temperature and pressure in which a solid and a liquid phase of a substance can coexist. And so if we think back to our phase changes here, going from a solid to a liquid is going to be melting. So this line here is the point at which melting can occur. And remember, with melting, heat is required. But also too at this line, if we go from a liquid to a solid, that is the point at which freezing can occur. Now with freezing, heat is released. Okay, so now I'm going to talk about our other 2 lines here, and I'm going to talk about this line here that separates our solid from our gas. And I'm going to circle this here, this line, in purple. Now, this purple here is a line that shows the temperature and pressure in which a solid and gas can coexist. Now, at this line, we can have 2 phase changes occur. Number 1, we can have sublimation occur. Now, remember, sublimation requires heat. Now what we can also have occur right here at this line I circled in purple is we can have deposition occur. And remember, with deposition, heat is released. Okay, so the last line that we need to talk about, and the last part of our phase diagram here, is this line that separates a gas from a liquid, okay? And I'm going to circle this in red. And this line here that I've circled in red is the line that shows the temperature and pressure in which a liquid and gas can coexist. Now, if a gas and a liquid can coexist, what we can have here is vaporization can occur. And remember, if we have vaporization, it's going to require heat. Now, if we go from a gas to a liquid, we can have condensation occur. Now, if condensation occurs, heat is released. Okay, so I know a lot is going on here just in this page alone, but it really ties together everything that we've talked about. It's important that you are able to identify each state of matter, where those phase changes occur, and these 2 points, the triple and the critical point, and what they mean. So this is the final part of chapter 13 where we're talking about states of matter. This is also the final part of this particular section. So I hope you've enjoyed it. Make sure you hit that like button if you have. And if you haven't done so already, make sure you subscribe.